All right, once again, warm-up number 97. For number 1, it says rewrite each expression. And once again, part A, B, and C, just like last week. Part 2, it says if x to the third times x to the fifth is x to the 3 plus 5, which is x to the a, then rewrite 2 to the x minus 6. Number 3, rewrite part A is 1 to the 1/2 power, B is 81 to the 1/2 power, and C is 64 to the 2/3 power. Number 4, graph f of x equals 2 to the x, then transform with g of x equals 2 to the x minus 4 minus 3, bless you. And number 5, get all the trig functions, sine, cosine, and tangent of that right angle. The hypotenuse is 13, and the two legs are 12 and 5. So, looking at it through the reference angle B. Let's see how you do with that. All right, here we go. Let's see how we did. Number 1A. Put that over 1. The reciprocal. So that is 1 over 5 to the second, which is 1 over 25. Hands if you got that. Okay, good. B, distribute. Careful not to spill your stuff. 1 to the negative third or 3 to the negative third. Do the reciprocal. So we end up with 3 to the third over 1 to the third, which is 27. Yes? All right. Next, C. What was this one when it was inside? 25. So this is square root of 5 times square root of 25. That means this is square root of 5 times 25. That means square root of 125. Hands if you got that. Okay, good. Man, you guys are in the row. Number 2. What'd you get for number 2, Nicholas? 2 to the x over? Number 2?
2 to the x over 2 to the 6.
Which is?
I didn't do like all the way.
Or you can't see it? Or? Yeah. 64. Number 3. Congratulations.
Thank you.
Yes, good job. 1 to the 1/2 is square root of 1, which is 1. That means this one is what? Square root of 81, which is 9. Which means this one, 64 to the 2/3, is 64 to the 1/3 times 2. Which means this right here is cube root of 64 to the 2nd power. So, Pablo, what number times itself 3 times gives us 64? 4, yeah. And then we have the square, which is here. That means 4 to the second is 16. Number 4. The graph for f of x equals 2 to the x is like this. It's an exponential. But then we're going to move it according to this. Pass someone, Pablo. Sebastian, where is it going to move to according to this?
4 to the right.
4 to the right
3 down.
and 3 down. That is correct. 4 to the right, 3 down, so it's somewhere over there. All right. And let's go with our last problem right here. This is C, and this is A. So I need a sine angle B. I need a fraction. According to this, they want us to focus on angle B, which is that. Sebastian, pass someone. Justin. Well, according to sine, it says opposite side over the hypotenuse. So here's angle B. What side is opposite to B? 5 over, which is my hypotenuse. 13, yes, the longest side. Tell your neighbor what the hypotenuse is. The longest side. Yes, that is correct. That one. All right, let's go to cosine. Pass someone, Justin. Yo. Cosine. It says adjacent side over hypotenuse. 12 over 13. That is correct. Tangent angle B. Pass someone. Vince, what you get for tangent? It says opposite over adjacent. 5 over 12 is correct. And we'll leave them as fractions for right now. Yeah, is that all right? Yes, Mr. Q. All right, good. Let's move on. Agenda. Copy this. Warm-up number 97. Logarithmic functions. And home plate for tonight, pages 771, 772, all only. Copy that and get a Cornell note, please. Ready? No asynchronous code today. Your previous home plate was to have a nice weekend, yes. We took a pop party on Friday, so those of you that were absent, make sure you come in tomorrow during the academic support time. Come take that. It's on logs. And your home plate for tonight, 771, 772. You can find that in Canvas in the new module for logarithmic functions. It's already in there. Okay? Yes, Mr. Q. All right. Y'all ready? Once again, today's the lesson is packed with stuff. That good job that you have a lot of energy today and you rested yesterday. Very good. Because we have a lot to cover. And we're going to start with transformations today. So, here we go. Our objective for today, I can graph and transform logarithmic functions. I can graph and transform logarithmic functions. So what are we doing today? Graphing and transforming. And what are we focusing on today again? Log functions. Do we need a Freire model? I see some of you say no. That means you know the definition by now, yes? All right, turn to your neighbor, let them know the definition of logs. What is the definition of log functions? Después de que se termine la lección, te voy a decir más o menos cómo recorremos la lección en la clase. Let's see, I think Jehu and Sebastian were engaged in a very deep conversation, but Jehu went last, so he passed someone. Oh, wait, who went last? Vince, pass the one. What are log functions? What? I thought you guys were ready. Let's see, someone that I haven't called on yet. Pablo, log functions are inverse of an exponential function. Let's go. The inverse of an exponential. The inverse of an exponential function. Yeah, so the inverse of an exponential function. Okay, keep that in mind because we're going to need that for today. All right, here we go. We covered this, yes. Then we did this, and this. So far so good, yeah? Okay, y'all ready? All right, copy this. Example Q. It says graph f inverse of x equals log 2 of x, and f of x equals 2 to the x. Here are the tables. Here's the coordinate plane. Copy that and make it from negative 10 to 10 both on the x and the y. Copy that, please. I'll give you some time. All right, let's do this one together. Ready? I'm going to use red for this red one right here. And if you notice, this is an exponential. Yes? Yes, Mr. Q. So here we go. I'm going to start with 0. So look up. What is 2 to the 0? 1. Yes. Next. 1. What is 2 to the first power? 2. What is 2 to the second power? 4. 2 to the third power. 8. We'll stop right there. Okay, so we go. 0, 1. 1, 2, 2, 4, 3, 8. Then you graph your function. There it is. Okay. Are we there so far? Yes, Mr. Q. All right. Now check this out. Put your thinking cap on. According to, who went? Oh, Pablo. Pablo said that a logarithm is the inverse of an exponential. Isn't this an exponential? Exponential, yes. So if this is the inverse, that means we do this. Copy this, please. Copy that. And label it y equals x. Okay. Are we there? All right, put on your thinking cap on. Here we go. I'm looking at this point right here. Look up to the screen. This one. What would be the inverse of that point, being that we're looking at the log, right? What would be the inverse of this point? Talk it over to your neighbor. What would be the inverse? Inverse of that point. All right, inverse. Let's see, I think Jessica's got it. What would be our inverse of this point, Jessica? I'm sorry? So give me the point. Okay. How about, I think Jaden's got it. What do you think, Jaden? Close. That would be the negative part of it, not the inverse. Jessica was right. We're looking at a mirror according to this. A mirror according to the x, y equals x. So 8, 3, its inverse would be what, Daniel? Who's got it? Help us out. I think Sebastian's got it. Go. Close. That's the same idea as well as the other one. There goes the inverse. Ready? If this is 3, 8, its inverse is 8, 3. You guys see it? If this is a mirror. Same distance here, same distance there. All right, so what is this point? 8, 3. I'm going to write it here. 8, 3. Now let me show you with algebra how to get there. I'm going to use this one right here, and I'm going to write f inverse equals log 2 of x. But instead of x, sorry, let me change that with a parenthesis. Look, I'm going to use this value, 8 and 8. All right? What would be my next step? Y equals log 2 of 8. Next step. Y to the what? Oh, my bad. 2 to the y. 2 to the y. 2 to the y equals 8. That is correct. And then 2 to the y equals 2 to the what? 3. So that means y equals 3. That's how we get that one. Let's do another one. So look up. If this x value I use what? 8. What would be the next value right there? Tell your neighbor, please. Yeah, 4, because we're using these, yes? All right, so let me get you started. F inverse of 4 equals log 2 of 4. Find me the inverse of x. All right, continue, Nicholas. What do I write?
Y equals y 2
And then?
2y equals 4.
And then?
2y equals 2 squared.
So that means that y equals 2. Y equals 2. And it goes right there. Now, do I need to show the work for the other stuff? Or can we know what goes here and here? Tell you what goes there and there. Yeah, 2, 1, and 1, 0. Let's plot those points. 1, 0, 2, 1, 4, 2. By looking at it, do you see that it's inverse? Do you see that it's a mirror image? Yes? Yes, Mr. Q? All right, good. All right, so check this out, guys. This parent function is log 2 of x. Log 2 of x. We're going to be using this one a lot. Okay? So I'm going to give you 2 more logs. Write them underneath. Write these right underneath that. Make this table. Write those down. Leave plenty of space in the column so you can fit like a coordinate plane on each. Leave plenty of space so we can graph on each one. We got f of x equals log 216, f of x equals log 100, and f of x equals ln x. And write that in blue and I'll explain why. So here we go. I'm going to start with the last one, this one. And notice these two look kind of weird, don't they? Okay. This one more because now it has ln in it. It doesn't say log. However, it is a log. This one is known as a natural log. But instead of writing natural log, they wrote as log natural, or ln. Now, why is that, Mr. Q? Because that one represents a particular variable that we use a lot in statistics and number crunching in the world, such as business world and such. ln stands for the letter E, which is 2.718. Write that down right above that in blue. E is approximately 2.718. Therefore, let me start with that one. First things first, I'm going to change this to y equals ln x. If I was to rewrite that again, then check this out. The ln becomes e. And what goes right above e? The exponent of y, and all that equal to x. And we'll leave it at that. Okay? Let's go to this one. What does this become right here, guys? We've done this before. Yeah, y equals log 2, 16. And then 2 to the y equals 16. 2 to the y equals 2 to the what? 4. That means y equals 4. Next. Once again, this becomes what? Y equals, and I'm going to write log. Now watch, look up. Whenever you don't have a base, the base will always be 10. Let me repeat that again. Whenever there is no base for the log, you would always write what? 10. Whenever there's no base, you write 10, then I'm going to bring down to 100. Continue from there. Edwin, go. 10 to the y equals 100. 10 to the y equals 10 to the what, everyone? Second. So this is y equals 2. So what's new? What's new is that when it doesn't have a base, we're always going to write what? 10. And whenever we have an ln, or a natural log, instead of ln, we're going to write what? E. Okay? Now, underneath that, you have space, yes? Yes, Mr. Q. Copy this. Here are the tables with it. Copy those underneath one. I'll give you some time. Ready? Go. All right, let's see. For the first one, guys, and by the way, all these are parent functions. All of them are parent functions at the parent graph. For the first one, I'm going to add, check this out. How many points do we have here? 1, 2, 3, 4. So they gave you 1 and 2, which are here. I'm going to add one more, which is this one, which is, add that right there, please, 4, 2. So from now on, guys, when I ask you to graph, when I ask you to graph this parent function, you're going to graph using 3 points, not 4 as it shows right here. I just gave you the 4 so you guys can see it. But from now on, you're only going to use this point, and this point. You guys get my point? Pretty good, right? Pretty good, yeah? This one, of course, 1, 0, 10, 1. And this one, of course, 1, 0, and E1. I'm only going to use these 2. Okay? All right. But all of these are what? Parent functions. Because why? F of x, and f of x. Okay. So by now, we should know how to transform these if I gave you the parameters, yes? So copy this down, please. Not this one. Look up. This is our general rule, right? So we know what A does. B, H, and K. Do we know how? Yes? Tell you never what those 4 things do to the function? All right, so A stretches it vertically or it compresses it. B stretches it horizontally or compresses it. H either moves it to the left or to the right, and K moves it up or down. So now, how does it look like now with logs? Copy this. Now this is our new one. Copy that, please. Not this one, but that one. G of x equals A log B, x minus h plus k. And once again, for the sake of time, k goes up or down. Up if it's positive, down if it's negative. H go side to side, to the right if it's positive, to the left if it's negative. It stretches or compresses if it's a whole number or it's a fraction, vertically or horizontally, right? Now check this out. Since a log is the inverse of an exponential, h is also vertical asymptote, which means we write x equals something, yes? Okay. We got it? Okay. So before I do anything, look up. Let's say I gave you this. What's the base of this log? 2. But where is that going to move to? Tell your neighbor where I'm going to move that one to. Where do I move that one to? Yeah, 3 to the right and 4 up. That is correct. There goes another one. G of x equals log 10 x plus 5 minus 2. Where would I move this one to? Left 5 and down 2. That is correct. So let's put that into practice. Here we go. Example 5 says graph t of x equals log 2, and I'm going to cover this table for right now. Copy that. Graph t of x equals log 2 x minus 5 plus 3. Alright, by looking at it, what is the base of this log, everyone? 2. That means the parent function is f of x equals log 2 of x. Is that correct? Which means, what were the 3 points that I asked you to use in the graph for this parent function? 1, 0, 2, 1, 4, 2. That is this one. Okay? How do I know? Because there's only 3 graphs, 3 parent functions, right? You copy them, yes? How many parent functions? 3. Log 2, log 10, and log e, or natural log. Okay. Now check this out. By looking at it, does it have anything next to the x? Anything here? No. So that means my VA is x equals 0. Here's 0. And my VA, vertical asymptote, it's right there. Okay. So with that said, we're going to move this one according to this transformation. Tell your neighbor where we're going to move it to. Where do we move it to? Dominique, go.
5 to the right, up 3.
5 to the right and up 3. That is correct. But before we do, look up. What is our VA? What is our VA? It's the number 5, so x equals 5. So let's go to x equals 5. It's right here. So we get our vertical asymptote at that point. And now we move each of these points 5 to the right and 3 up. So watch. 1, 2, 3, 4, 5. 1, 2, 3. This one. 1, 2, 3, 4, 5. 1, 2, 3. This one. 1, 2, 3, 4, 5. 1, 2, 3. Oh. There you go. Write this down on that same one. G of x equals log 2 x plus 2 minus 3. So you never were to move that 2. And what is the VA? What's our VA for that one? All right, VA, Lynn, go. -2. So let's go to -2 of x, which is right there. Yes. And where are we going to move that to, Samantha? To the left, 2 steps, and 3 down. So we're going to go to the left, 1, 2, and 1, 2, 3. This one, 1, 2, 1, 2, 3. And this one, 1, 2, 1, 2, 3. How are we doing? Yes? All right, let's do one more. And I think Maritza's got this one. Let's say I gave you g of x equals log 2 x plus 3 plus 4. Saying over the VA for this one, x equals what, and where it's going to move to. All right, Maritza, go. VA is -3, so at -3 is right here. And where are we going to move it to? 3 left and 4 up. So we go 1, 2, 3, 1, 2, 3, 4. This one, 1, 2, 3, 1, 2, 3, 4. And this one, 1, 2, 3, 1, 2, 3, 4. From 1 to 5, how comfortable are you with this? Transformations, 4, 5, 4, 5, okay? But this is what? Base 2. Do we have a transformation here for stretching or compressing? No. Well, let's add one of those. Check this out. Look at this one. Hold on. Writing utensils down. Don't copy this. Once again, what is the base? 2, right? So my parent function is at 1, 0, 2, 1, 4, 2. And then the asymptote at 0. Okay. Now check this out. This one, before I move it to the right 4 and 5 up, I need to do this. So what is that? I need to multiply the y values for these 3 points times 3. So what is 3 times 0? 0. What is 3 times 1? 3. What is 3 times 2? 6. So at 4, instead of 2, it's going to be 6. And now I can move it in which direction? 4 to the right, and 5 up. 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And my VA is what? 4, let's see. Yes? We'll stop right there. Once again, your home play for tonight is found in pages 771, 772, all only. Once again, make sure you do your practice. Have a good one. See you guys tomorrow. Bye.